A warm welcome to everyone. Our case study is Beyond on Signal Flow Graph by S. Priscilla, S. Shiny, and R. Dakshana. Signal flow graph. A signal flow graph or signal flow graph invented by Claude Shannon, but often called as Mansion graph after Samuel Jeffrey Mansion, who coined the term. A specialized flow graph, a directed graph in which nodes represent systems, variables, and branches, represents functions connected between pairs of nodes. Thus, signal flow graph theory built on that of directed graph, which include as that of their oriented graph. This mathematical theory of this graph exists, of course, quite apart from these applications. Signal flow graph for analysis and design. When building a model of a dynamic system, a list of steps is provided by draft and bishops. Define the system and its components. Formulate the mathematical models and the list that needed exceptions. Write the differential equation described in the model. Solve the equation for the desired output variable. Examine the solution and the exceptions. If needed, reanalyzing or redesign the system. This is workflow explanations of the physical system. Mathematical models are used to derive the signal flow graph equations. Signal flow graph for design synthesis. A signal flow graph has been used in design space explorations as an interpretive representations towards a physical imitation. The TSC process seeks a suitable solution among different alternatives in contact with the typical analysis workflow, where a system of interest is first modeled with the physical equations of its components. The specification for synthesis or design could be a derived transfer function, for example, difference category who could create different signal flow graph from which implementations are derived. Another example is an automated SFG as expressions of the continuous time behavior as input to a agriculture generator. Problem 1. In the systems, there is only one forward path between the input RS and the output CS. The forward path gain is P1 is equal to G1, G2, G3. We see that there is 3 individual loops. The gains of these loops are L1 is equal to G1, G2, H1. L2 is equal to minus G2, G3, H3. L3 is equal to G1, G2, G3. This comes apart from the signal flow graph of the oriented. Problem 2. Note that since all these groups have a common branch, there are no touching loops, since the determined theta is given by theta is equal to 1 minus L1 plus L2 plus L3, where 1 minus G1 plus G2 plus H1 plus G2, H2, H3 plus G1, G2, G3. The cofactor T1 of the determinant along the forward path correcting the input nodes, and the output node is obtained from theta by removing the loops that touch the path. Since path P1 touch all 3 loops, we obtain. Therefore, the overall gain between the input RS and the output CS or the closed loop transfer function is given by CS divided by RS is equal to G1, G2, G3 divided by 1 minus G1, G2, H1 plus G1, G2, G3 plus H2 plus G1, G2, G3. Here the problem 2. Using Mansion formula that the T of F as C or RS is determined by C divided by R, like P1 by theta 1 plus P2 by theta 2 divided by whole. Here the whole numbers are grouping together to divide all the whole numbers in a same way. Problem 2. Draw the DFT from the flow graph given below. Choose the nodes to represent the variables is 1, 2, 5 as shown in the block diagram above. Connect the nodes with appropriate gain along with the branch signal. Thank you. By S. Priscilla, R. Dakshana, S. Shiny Pyolin.